Welcome back to this tutorial. In the previous tutorial, we looked at how we can draw box plots, bar plots, and strip plots in seaborn from data frames. This time round, we want to look at joint plots, and is the custom. We import the seaborn library. If you already imported it previously, you don't need to import it again. And the next thing is to import, sorry, I have an error, imported as SNS. And then we import our data and assign it a variable name called df. Our data is in CSV format, so feel free to pause the video and download the data if you don't have it, but it's the same data set that you have been using previously. So again, if you imported it already, you don't need to re-import it again. And I will check the first 3 data points of this. So joint plots are very, very important when you want to compare 2 variables concurrently. So in this case, let's say I want to compare the total amount and the speed and have them within my same graph and also show the distribution. So they're very, very important. You can do them in seaborn using a single line, using the seaborn function called joint plot. And the first one accepts the first variable you want to use. Normally in machine learning lingua, we call it features, or basically the column names. So I'm going to have the total amount there. And then my y-axis is going to be, this case, let me use the speed. And then the data set, obviously, this should be very much easier for you now. And then kind, so let me just plot this so that you can have a look. So this is what it outputs. So if you want to show the distribution, you can add an argument here called kind, and this will give you the distribution. So let me have it as regression. So what this tells you is it draws a regression line and also shows you the distribution. So when we start getting into machine learning, you realize that basically what this line is the line of best fit. It simply tells you that if you have got if you are given a given speed here, chances are that the total amount will fall within this shaded region, and that is where most of the data set is concentrated. So instead of having this as regression, you can make it a 3D plot by simply changing this, but I'm just recopying it so that you can have a fresh Excel spreadsheet. And instead of kind here, we can make it KDE, kernel density estimation, and it's gonna generate the contours. So it tells you that where the contours are more concentrated, it tells you that that is where more data set are. And this one is an outlier. Again, if you are working as a data scientist, you will have to do away with this if you're going to subject this to a machine learning algorithm, because this one can easily skew your data or give you wrong predictions. So these are an anomaly. We can make this nicer by adding the shade function. So you can add it in there or just copy it the way I'm doing, but I'm doing this purely for illustration purposes. So I can make shade to be true, so that you can have more superior graphics. So if I run it, you're gonna see the darker it is, the more data is concentrated in that area. Of course, I can change this by adding an extra, make shade equal to true, and then I can change this color, CMap option. So here we use CMap, don't use palette. So let me use coolworm from the same table that we have been showing you. Now you see the red part is where the data is concentrated. So this one again is the anomaly. So that marks the end of using joint plots. Before we wind up this video, I want to show you something interesting, and this is going to be one of the first things you do with your data set, especially if you're doing machine learning or machine learning modeling with these algorithms. So there's a very, very important concept of correlations, And correlation basically shows you how two variables are related in a data set. So let's take a look at our data set. I'm just gonna call it here, call the first few lines. So if you look at this data set, it has got different features or columns. So each of these columns may be related to the other or not. For example, the driving experience is surely related to age. Why? Because the more somebody is aged, the higher the chances that they have drove for a long time. The speed might be related to gender. I don't know, between female or males who are more thrilled by speed. The total amount might be related to speed, in that the people who are like overspeeding are likely to be fined. So that kind of correlation might happen. In some cases, there might be a negative correlation where one or an increase of the other leads to a decrease of the other one. So the concept of correlation is very important when you have got multiple columns that you want to use or you want to input into your algorithms. So in most cases, you don't need to use all the columns, and that's why you want to see how these data sets are related before you apply this correlation. So the easiest way to know the correlation or how each of these columns are related to each other is using the correlation function. So our data set is df, and the correlation function is simply CORR, which is an inbuilt function that allows you to calculate the correlation. So you can see total amount to total amount is strongly correlated. So the highest value of correlation is always 1. So if it's closer to 0, then the correlation is 0, is very, very small. If it's negative, then it means the correlation is it means it's inversely proportional, meaning that an increase in the other probably leads to a decrease in the other. So they are opposite to each other. So negative correlation is good, also positive correlation is good. Correlation of 1, it means it's the same thing. So it's a very strong correlation. So this is a correlation table, but you realize that having a look at this is difficult because it's very, very many numbers to process. So there comes an important concept of heatmap that is provided by Seaborn library. So heatmap does this as in a graphical way. As we always say, a picture is worth 1,000 words. So if I do SNS heatmap using the heatmap function, and then I do the correlation, I simply copy this and have it inside here, and then comma, I will annotate to mean true, and then have the color. So I'm gonna use the yellow, green, and blue, and that way I will generate my heat map. So if you look at this, let's take a look at the first one. The correlation is negative 0.44. So that is the correlation between total amount and driving experience. So it means they're negatively correlated. If you look at speed and total amount is very strongly correlated, is 0.5. It means the higher the speed, the chances are that the more amount you will be charged as fine. The age and the total amount is not very correlated. It's negative 0.44. And then you see 1, it means there's a very strong correlation between total amount and total amount, which doesn't make sense. It's the same thing. I want us to look at this correlation here, driving experience and age. You can see there's a very strong correlation of 1 and 1, which means the older you are, the more driving experience you are likely to have, and the younger you are, the less driving experience you are likely to have. And then you have got a bunch of ones along the diagonally, which basically means correlation between the same variables. So driving experience and driving experience, previous offense with previous offense, same. So this one kind of gives you idea in your data science analytics to know which columns you are likely to drop. So in my case, if I was working on this data set, I might know which data sets I want to drop. Remember, the top part of it is simply the replication of the bottom part, and you can always eliminate the top part by using a numpy function. So first of all, I'm gonna do import numpy as np, And then I'm going to create a mask that will basically mask this part. So how do you do that? To do that, you're going to generate a series of, if you remember one of our tutorials, we look at how to create an array. So I'm going to create an array that consists of, that is filled with all ones. So to do that, I'll just use the numpy and then use the try function in numpy, and then generate a numpy array that consists of 1, but the size should be the same as this one, which is our df. So that is why I'm gonna do like ones, like the correlation of our data frame, and then this will be our mask. So I've created a mask that is exactly the same as this heat map, but it's filled with ones, and then I'm gonna use it to mask the part that I don't want. So that is what is going on. So to create now the heat map, I'm gonna do heat map. Remember, you only do it if you are not able to, if you don't like the other part, but if you like it, you can leave it at this point. But I think it's just good to show you so that you can use this for presentation purposes. And then the color map, I'm gonna use the same. Let me use a cool one this time, and then set annotation true, and then I'm gonna have a mask, which is my mask that I've just created. Then run this. So you can see this is now our heat map that is condensed. So this is how you use correlation, and heat map is very, very important for preliminary data checking. This will be very, very useful when you start machine learning, to know which columns that you need to drop so that your algorithm or your machine learning model can train faster and it doesn't overfit. So you'll know what that means in our next sections. So as is the custom, please subscribe. If you like the video, give it a thumbs up. Tell a friend to tell a friend. For now, bye bye.